Hello everybody, welcome to our third circuit problem. So this one's more conceptual. Here we have a circuit and we put we have a battery of course, and we have a voltmeter going across the battery, and that's denoted with this instrument over here. We have a switch, and we have an ammeter. An ammeter of course is over here, and voltmeters measure voltage, ammeters measure current. So with the switch is open, this voltmeter reads this battery as having a voltage of 9 volts. And obviously, if the switch is open, there's zero current going through the entire circuit. So the ammeter reads 0 amps. That's a 0, of course. And when the switch closes, something mysterious happens. We see the voltage drops to 8.4 volts, yet the current increases to 0.8 amps. So try and come up with an explanation for what happens here. Okay, so the explanation is this is kind of like a real world example. Every example we've done so far, we've assumed that the batteries were ideal. Actually, no, in the last video we did internal resistance. But yeah, that's exactly it. There's internal resistance in this battery. So we can say that there's a little resistance inside the battery with some little resistance, call it lowercase r. And when the switch is closed, then current flows through this resistor, and therefore there's a voltage drop across it. So now there's voltage across this guy. Let me actually draw this resistor out here. It'd make more sense to put it outside. So yeah, now when the switch is closed, there's this resistor is now having a voltage drop across it, and this kind of eats up more voltage than the battery, so its voltage is going to drop a little bit. And now the next problem, not really to just find an explanation. Now, let's try and calculate what this internal resistance is. That's the problem. Well, to calculate this internal resistance, hopefully you noticed that there must be a voltage drop of 0.6 volts across this little resistor, because now the voltage dropped by 0.6 over here. It starts from 9, and now it's 0.6. So over here, across this little resistor, call it 0.6 volts. And we know that the current through the circuit is 0.8 amps. So that means if we were to draw some kind of current direction going through, it must go through the battery, and it must also go through the resistor. So the same current that's going through the ammeter must be the current going through this resistor. So we have a voltage, and we also have a current, 0.8 amps. So now I think we have enough to solve for our internal resistance, because we know that V equals I little r. So V divided by I must give us little r. So let's plug this stuff in. We get 0.6 volts divided by 0.8 amps, which is essentially, this is 6 over 8. So that's going to give us 3 over 4 volts by amps, or 0.75 ohms. And that's our internal resistance of the battery. And it makes sense because it's a very small value. And yeah, this is a very good real life example of something an observation you'd see at the workbench.